I'm going to do an example on integration by parts. So let's first of all write our formula for integration by parts. And let's also note our order of picking the u's. Okay, the example we're going to do is, well, this is kind of not very clear, is it? Okay, that's the I for inverse trig. Log for L for logs, I for inverse trig, P for polynomial and powers of x's, E for exponential functions, and then lastly T for trig. The question we have to do is this. And basically the rule for picking the u suggests that you should pick the exponential to be the u and the trig cosine of x to be the dv. But actually at the very end of this list, the order doesn't matter. It's not going to be an efficient question whether you pick exponentials as the u or the trig as the u. But I will follow the rule of Lipet. So I am going to pick u to be e to the x, and then its derivative is itself. And then I'm going to pick dv to be the cosine x dx. b is going to be sine x. It's always tricky with the trig, so make sure that you have the sign right. So sine's derivative is cosine, so we're fine. And let's switch color for emphasis. We take that, so our answer is e to the x sine x minus the new integral you get from here, which is e to the x sine x now. So what happened when we applied integration by parts is we ended up with this part, which is fine, and then a new integration. And this new integration we have is basically at the same level of the question. So this kind of shows you didn't pick your u or v in the wrong order or anything. But what we do have to do is do by parts one more time. Okay, so we have to do by parts one more time to this question we have. But I am going to take it to the next page, alright? Okay, so here we are. Our u is e to the x, du e to the x, and dv is this time a sine x, and its antiderivative is going to be a negative cosine x. Our answer lies in this diagonal, and we are at e to the x sine x minus now the answer to this antiderivative, which I will use parentheses for, and it is e to the x times negative cosine of x minus the new integral we get from here, which is going to be e to the x times negative cosine x dx. And this simplifies to e to the x sine x plus e to the x cosine x plus, and then minus, minus the integral e to the x cosine x dx. Okay, so let's maybe zoom out to see where we are with this question. The question we had to answer was e to the x cosine of x dx, and the answer we found to it so far seems to be e to the x sine x plus e to the x cosine x minus yet another integral, but that integral is the same as our question. So things do not cancel on both sides, but what they do is they double up on the left hand side, and so 2 times the integral we wanted to find the answer to. Seems to be this answer. And so the answer to our question is e to the x sine x plus e to the x cosine x all over 2 plus a constant. And we are done.